Hello to all our spectators and welcome to this emission. My name is Johan Daniel García Salcedo. Today we'll be with Adolfo Alejandro Arenas Ramos, a student of the prestigious University Francisco Paula Santander. Hi Adolfo, how's your day?
Oh, I'm pretty excellent, Daniel. Thanks for your space.
Thanks to, in this time I have an interesting theme to today's talk. Well, I was looking for information about this topic in the library and I found some interesting tests. We could make some question about that. Data structures, like assistant engineering student, probably you know about that.
Of course, that's one of the most important topics in my career. What's your question?
Let's begin with some basic. Why do data structure matter for training an information system developer?
The importance of a system falls not only in if complete a function or not. It's necessary to form an efficiency of this function, striving for processing speed, computer power, the load that impart on the system, and how management is distributed across its components.
Okay, Adolfo, and in what kind of computational problem is necessary to have appropriate management of data structures?
If we start with the premise that every application and system must use data and information, then data structure is always necessary to find the appropriate and optimal way in which the application and system handle and manage this data, saving, transferring, traffic, and distribution of information is where these structures are applied. And any problem related of these, it's a problem that warrants adequate knowledge about it.
Why do others define data type as primitive data structures?
Because initially it's defined that the data types used in the field programming and structured in them to save their times, information, characteristics. Thus, this type of data is what the machine manipulates with our instruction, and they can be used within more complex data structures.
Hey, that's awesome! And what other utilities can be obtained of two data structures?
Well, it's interesting. In case of the array, we call work as a buffer to store temporary data and access it quickly. In addition, it can maintain its position and size over time, even if elements are deleted and new ones are added to positions remain the same.
What about the stack?
It could serve to go back or return at a previous point in a software algorithm, keeping a record of the changes that are made in, like the back button of a window or tab panel. And also, the restoration points are an example, such as backups in gamers and systems. They behave like stacks.
Curious. And what can you say about the queues?
It can be used in processing in systems where the order of start is criticized by user choice, such as download manager. It can be used in systems where, due to limited capacity of the randomness of data arrival, an order is required to process them out, like shift software.
And what happened with the linked list?
It has a very particular and useful functionality, such as expanding and contracting according to the numbers of elements that are removed or added, unlike an array. And in the same way, it allows us to add or remove elements from any position in the list, which is especially useful if you are looking to correct or relocate an element in the list without having to delete.
I think the trees have an awesome functionality too.
It can be implemented in such a way that resource, event, or process used and executed in isolation, in case it's related to a larger one that contains it, as in the case of games, or in decision-making software where the execution or events is optimized according to the route taken in the progress.
At last, what could you say about the graph?
It can be implemented in recommendation or suggestion systems such as social networks, where friends, preferences, and trends are suggested to us based on the connections that form us with our contacts and interests. And additionally, this structure can also use in a dependency system where a software or system maintains a dependent or codependent relationship with another system where these two will be nodes.
These relationships sound complicated, really. Don't remember me a phrase in one paper I read. I think you know the rule of data structure in multiple disciplines or computer science, and the others mention it in one part that in organizing a solution and problem solved, with the aid of computer machine confront with some problems, including to understand totally and relationship between data element items that are relevant to solution of problem.
Well, I think that they refer to the problems that keep relation with the operations, use the data and information being honest.
That makes sense, but now I want to ask you, why should every developer learn data structure and algorithms, and why are data structures so important?
Well, there are a lot of reasons. It's not enough just a program and code system or software. A good engineer must look for the best way to do a task and solve the problem with this work. Primary data types are not enough to organize and process the data, and it's essential to write clean and optimized code.
Well, just let me make you last question. What do you consider was the most important contribution of veterans to main training as a system engineer at UFPS?
Primarily, it contributes to expanding the panorama of the ideas that are held regarding systems, because it's often not thought that only the algorithm or the formula that is followed, but modeling, design, and implementing them is important. But it often goes unnoticed that all these systems are nothing more than processors and administrators of data, information with which the machine does things by our orders, and as such, we have to strive and design our project with the vision to make that machine not only work, but do it well.
That is all, Adolfo. Thank you for being here, and that's all.
Thank you for
Thanks
your
for
time,
watching.
Daniel.
Thanks for watching.